Today we are going to discuss about force and moment of force. Now, as we have discussed in class 9 and 8, what is force we are knowing? Force is the physical cause which can change the state of the object. It can change the dimension of the object. Change of state means what? From rest it can start motion, from motion it can stop, it can change the direction of force, it can change the direction of motion. So these are the different effects of force. Now in class 10 we will start from the effect of force, different type of effect, that is especially the different type of motion. So first we are going to start linear motion or translational motion. So here we are considering an object, which is, this is the object on which we are applying a force. This point where the force has come in contact of the object, this we call point of application of force. And the direction, this one is the direction of the force in which it is applied. If we consider an imaginary line in the direction of force, this line, this we call line of action of force. So for translatory motion or for rectilinear motion, that is motion along a straight line, what should be? The object must be free to move. We will have to apply a force, and the other condition is the line of action of force must pass through center of gravity of the object. Otherwise, it will have mixed motion. It will have translational as well as rotational, both will take place. So for pure translatory motion or for pure linear motion, the line of action of force must pass through its center of gravity. Now what are the other, this is the condition for translational motion. What are the characteristics, other characteristics? So here you see, when we apply the force, this object has displaced from this point to this point, or this place to this place. If you consider this any point, any particle, suppose this is the point A. This point has displaced from this place to this place, this is A dash. So A has displaced from A to A dash. Another particle, suppose this is B. This B has displaced from B to B dash. Whose displacement is more? This is displaced from here to here. This is displaced from here to here. Whose displacement is more? So here both the particles' displacement is same. The displacement of all the particle of the object will be same. This particle's displacement, this particle is displaced from here to here. This is displaced from here to here. So all the displacement will be same. Time is same. In same time it is displaced. Naturally speed will be same. So in this type of motion, what will be? The particles displacement, velocity, acceleration of all the particles of object will be same. These are the characteristics. So here for translatory motion, the object must be free to move and line of action of force must pass through center of gravity of the object. In translatory motion, displacement, velocity, acceleration we can say, and acceleration of different particles of the object are same. So this is the condition, and this is the characteristics of translatory motion. Now we will discuss rotational motion. So in rotational motion, this object is free to rotate or move about a particular fixed point, and this particular point we call, either we call it fulcrum or knife edge. It may be free to rotate about a line also, like the door. Door is free to rotate about a line passing through the, or along the line joining the hinge, that we call axis of rotation. So in this rotational motion, the object is either free to rotate about a point or is free to rotate about a line which we call axis of rotation. and here the line of action of the force must not pass through the point of rotation or axis of rotation. The line of action must be away, it should not pass through this point, otherwise it will not rotate. Now in this case, after displacement, particle A has come to A dash, so this is the displacement. B has come to this position B dash, this is the displacement. C has come to this place, so the displacement is here. So in this case, displacement of all the particles are different, but time is same. During same time, the A has come, when A has come to A dash, B has also come to B dash. So time is same, but displacement is different. Naturally, velocity will be different, acceleration will be different, displacement is different. So in this case, these are the characteristics of rotational motion. So for rotational motion, the object must be free to rotate about a point, which we call point of rotation, or about a line, which we call axis of rotation. And the line of action of force must not pass through the point of rotation or axis of rotation. That is the condition, and this is the characteristics. In rotational motion, displacement, velocity and acceleration of different particles of the object are different. They are not same, they are always different. Now I will discuss moment of force, or the symbol is this torque. So we define, as we have done in class 8, moment of force. So it is the turning effect of force and is given by the product of force and perpendicular distance. Perpendicular distance with what? Between line of action of force and axis of rotation, or it may be point of rotation about which it is free to rotate, either it about a point or about a line. So perpendicular distance between line of action of force and axis of rotation. This is the formula, force into perpendicular distance. So as it depends on these two things, force and perpendicular distance, so naturally what will be its unit? SI unit of torque will be what? SI unit of force into SI unit of distance. SI unit of force is Newton, SI unit of distance is meter. So its SI unit will be Newton meter, CGS unit will be dyne centimeter. So SI unit is Newton meter, the symbol will be Nm. If you are writing full, then small n, Newton meter like this, and dyne centimeter. As we know, 1 Newton is 10^5 dyne, 1 meter 100 centimeter. So 1 Newton meter will become 10⁻⁷ dyne centimeter. Its other units may be whatever the unit of force we are considering, whatever the unit of distance we are considering. As we know, the other units of force, kgf meter or kg weight meter, gf centimeter or gram weight. Gf means gram force, so gf centimeter or gram weight centimeter, kgf centimeter, whatever it is, one will be force, another will be distance. So we can give the dash, or we can give only a dot like this, Newton dot meter. Here dash is there, so both are correct, either Newton meter or Newton dot meter. In class 8 we have done Newton meter is also force into displacement is work, and the unit of work is joule. But here you are not supposed to use joule, here will be only Newton meter, no joule and no erg here. Here dyne centimeter means erg, but don't write here erg, it will become wrong. So unit will be here Newton meter, and work we can't write Newton meter, work will be joule only. Moment of force is a vector quantity, but it has got only two directions. One will be clockwise, another we call anti-clockwise. CW clockwise and anti-clockwise is CW. Clockwise means what? If this force has got a tendency to rotate this object along the motion of hands of clock, hands of clock is moving this way. So 3, 6, 9, 12 like that it is. So this is the rotation clockwise. So this force has got clockwise movement, and this one, it has got anti-clockwise movement. It has got a tendency to rotate the object opposite to the hands of clock. The clock is moving, hands is moving this way. It has got the tendency to rotate in this way. So this we call anti-clockwise. So this is anti-clockwise movement, and this is clockwise movement. So this, as it has got only two direction, clockwise or anti-clockwise, and both are opposite. So it is represented by two algebraic symbol. This anti-clockwise we call positive, and this clockwise movement we call negative movement. So it is represented by two symbol only, clockwise and anti-clockwise. Now what is the expression for moment of force? So suppose we are considering here two different cases. Here is the point of rotation O, A is the point of application of force, and force applied is F. Now in this case, see, the line of action of force is perpendicular to this. What does it mean? The perpendicular distance is itself OA. This angle is 90 degree. So in this case, this torque will be F into OA. But in this figure, the line of action of force is in this direction. It is not perpendicular. The line of action of force and the point of application of force along the line, if you join point of rotation and point of application, it is not making 90 degree. So here this torque is not equal to F into OA. It will become wrong. What will be here correct one? The magnitude of force and perpendicular distance is here this OM. So in this figure, this torque is F into OM. Got? Okay. Now what are the factors, or what should be the factors? Only these two, the force and perpendicular distance. And what is the condition for maximum torque? So we will have to apply force at maximum distance, and if this line of action of force become perpendicular, then also it will be maximum. So now what are the conditions for maximum torque? So for torque, that is moment of force, to be maximum, what should be? First is the force must be applied at the farthest point, that is whatever at the end we are applying, like on door also. When we are applying force at the last point, we have to apply less force, or we can produce more moment. Second is the angle between the line of action of force and the line joining the point of rotation and line of action of force must be 90 degree, like here angle is 90 degree. So these are the two conditions for maximum torque. Okay, thank you for watching the video. In next class we will see the principle of moment.